Hello, so today we're talking about molarity. The topic and goal short, sweet, to the point. Topic is molarity. Goal is I can solve molarity problems. So the reason why we have these calculations we're going to be talking about the next couple of days is because since solutions are homogeneous mixtures, their compositions can vary. Sometimes it's inadequate to refer to a solution if it's dilute or concentrated without knowing specifically how much it's been diluted or how concentrated it actually is. So since those just kind of are qualitative description, it's more precise to describe the concentration of solutions in quantitative measures or in numbers. So we're going to talk about how we can do that and the different formulas and different ways we can do that. The first thing we're talking about is molarity. Molarity is capital M, that's the symbol for it. And then you can also use it by saying molar. Like I have 6 molar of HCl. That means the molarity of that HCl is 6. So that is the number of moles of solute in a 1 liter solution. Okay, so here is the formula. Molarity is moles of solute divided by liters of solution. So if you want to type that in, if you don't want to make it a fraction like I did, you can always just put a line like that so you know that it's divide. Moles of solute divided by liters of solution. So, calculating molarity. A highly concentrated HCl has a molarity of 12 capital M or 12 molar. This means there are 12 moles of HCl dissolved in 1 liter of water because 12 divided by 1 is 12. So, here's a sample problem. How many moles of NaCl must be added to 6 liters of water to make a 3 molar solution? So we know it's capital M equals moles over liters. So if we fill this in, do we know what capital M is? Yes, this is a 3 molar solution. So we know 3 is going to equal the number of moles divided by the liters. Well, we don't know the number of moles, so I'll put X divided by liters, which is 6. So to do that, since 6 is being divided, in order to do that math, you'll multiply by 6 to get rid of it. So 3 times 6 is 12. So it'll be 12 moles of NaCl. What do you do if they give you grams? Step 1, change grams to moles by using molar mass. So to find molar mass is what we did last unit. You can use the periodic table. If you don't have one printed out, you can use ptable.com. I'll go ahead and pull that up because that's what I will use as a reference for you all. Okay. Then, now that you've changed it to moles, you can then plug it in to moles over liters to solve. So here's an example. If I have 43.3 grams of LIBR and 0.5 liters of the solution, what is the molarity? Well, first, this is basically like a one-step stoichiometry problem. So I'm going to make my railroad tracks. You're welcome to do this on paper. You do not have to do this in your digital notebook. Okay, so we start with 43.3 grams of LIBR. And we need to get to moles of LIBR. So if this is grams of LIBR, this is also going to be grams of LIBR, and the box up top will be moles of LIBR. Well, if you remember, the number 1 always goes with mole, and the molar mass always goes with grams. So for LIBR, since it's just one of each, we just have to add up Li, which is 6.94. Let me pull up my calculator. So Li is 6.94 plus BR, which is 79.9, 86.84. 86.84. So then we'll do the math. 43.3 times 1 is just 43.3 divided by 86.84. So 43.3 divided by 86.84. So that means we have 0.5 moles. So now that we know we have, I'm going to take that underline off. So now that we have 0.5 moles, we can now solve the problem. So capital M equals moles divided by liters. We do not know what our capital M is, so that's going to be our X, or we could just leave it as capital M. We know our moles is 0.5 divided by the liters, which in the question they say is 0.5 liters. So 0.5 divided by 0.5. So our capital M will be 1 molar. That would be the answer for that. So in your digital notebook, you have a chart you'll need to fill out. I give you the mass in grams, the liters, and then the molarity. Here's just some extra work or space if you need to do work. You can also work it out on paper and just put your answers on here. But for molarity, I'll put the formula up here for you. Capital M equals mole over liters. Now, I give you grams instead of moles. So you need to change grams to moles in order to do that. And that's why I give you the compound there, because you'll need the molar mass. So if you have questions on how to do that, let me know, and I will be happy to help.